Today, we will demonstrate Siemens StarCMM multiphysics computational fluid dynamics software deployed by UberCloud's engineering simulation platform and Vcinity Alt-X remote access software. We configured the benchmark to run with compute nodes in Azure's West European data center with data residing in the Vcinity data center in Maryland. All data was read and written to the Vcinity Maryland data center. 2 terabytes of NFS storage was mounted for the simulation. Vicinity's data centers is connected to the internet with a 750 megabit Fios connection. For compute nodes were used, each with 120 AMD EPYC cores and 448 gigabytes of RAM for a total of 480 CPU cores and 1.7 terabytes of RAM. Let's start by using the UberCloud self-service portal and select StarCMM and then defining the zone, computer type, and storage. Normally, it will take around 18 minutes to deploy. We will speed up the deployment and configure 4 compute nodes. Logging into the node and start the StarCMM GUI. To load the simulation, select the correct process options and check each host has 120 CPU cores available. Select the correct license and load the file from the Maryland Vcinity data center. As the file is being loaded, you will notice the Vcinity GUI showing the VAN bandwidth utilized during the load. This signifying the data being loaded from US to the compute nodes in Europe. On the StarCMM GUI, you will see the calculation of the simulation. For benchmarking, we have created a script to load, run, and save the results of the simulation. This script will be run twice. Once with data being accessed using Vcinity, and the second we will use cache to get faster results. As the script kicks off, keep an eye on the Vcinity GUI. You will notice the bandwidth spike up and then sustain at over 85% of the bandwidth as the simulation is run. Keep in mind the files are being read from Maryland to 480 CPU cores in Europe. After the simulation is completed, the data is being written back to storage in Maryland. Let's speed up to get the results. Zooming into the terminal output shows this simulation took 5 minutes and 45 seconds to run. Let's run the simulation again. Since this is the second time running, some of the data will be cached, resulting in a faster run. Vcinity provides the option of using cache. If cache is used, you can configure the size of cache to meet your application requirements. This time the simulation only took 1 minute and 41 seconds versus 5 minutes and 45 seconds on the previous run, resulting in 3x improvement in run time. We will do one final simulation run. This simulation will be getting its data from NFS server running in Ashburn, Virginia. Since we are not using the Vcinity Alt-X software, this will take longer. Let's fast forward to the results. Using NFS over normal TCP from Ashburn, Virginia to Europe, the simulation took almost 12 minutes to run. Vcinity is almost 2x faster without cache and almost 7x faster with caching turned on. Here is a summary of the results. For more information, please visit www.vcinity.io. Thank you.